Okay, in example 1, we're asked to sketch graphs of quadratic functions in vertex form. So they're in the form y equals a times x minus p squared plus q. Okay, so if you look at this one, or question A, p, x minus 1, so x minus negative 1 is what gives you x plus 1. So p is negative 1, q is negative 3, and a is 2. Okay, so what we're going to be looking at, if you look at those three values, we're going to be looking at a graph with that's a little bit narrower than our standard y equals x squared parabola. It's going to open up because a is positive, and it's going to have its vertex at x equals negative 1, y equals negative 3. Okay, so we can just draw that. Sorry, just let me grab myself a piece of graph paper. There we go. Let's make that a little bit smaller. Sorry about that. Okay, I'll put my x and y axes right here. Okay. And okay, so we'll start by graphing our vertex. So our vertex we know is just PQ, so negative 1, negative 3. Okay, so this is the origin. Here's my vertex. Okay, I know it's going to open up. And so one thing that I can do here is I can just make a little table of values. Okay, and I can just make maybe 2 values. Normally I would do more. Normally I would do probably 0, 1, or sorry, negative 2, negative 1, negative 1, 0, 1, 2. In your book, they only ask you to find 2 or maybe even 1 other point, I think, when you're graphing a parabola. Okay, so, but yeah, I mean, if I put x equals negative 1 into my formula, or negative 2, I get negative 1, 2 times 1. So I get y equals negative 1. If I put x equals negative 1 in there, it's negative 3. I know that. That's my vertex anyway. When x is 0, y is negative 1. And I mean, these are not necessarily good points. They are in this case because our vertex is at negative x and negative 3, but they might not necessarily give us points that are on both sides of our vertex. In this case, they do. Okay, so I can just graph a couple of those points. I marked the origin there, but that's not actually a point on our graph. Okay, so when I set x equal to negative 2, I found that the corresponding y value was negative 1. Okay, I also found that when x was equal to 0. Okay, and I can find another point, just to be a little more confident about the shape of my graph. Put x equals 1 in there, so 2 times 2 squared, that's 2 times 4 is 8, minus 3 is 5. Okay, so my next point is going to be at x equals 1, y equals 5. Okay, so it's going to be just like, okay, then you try to draw a nice smooth parabola that goes through those points. Okay. You can mark this point because it's just if this is the axis of symmetry, which I was supposed to graph. Sorry, I got a little ahead of myself. We have the point that we've figured out, and it's reflected through the axis of symmetry, right? They're the same distance away. Okay, so the vertex is negative 1 and negative 3. The domain, okay, well, when we have this kind of parabola, the domain is always just the set of real numbers. All right, and we can write that as x values where x is any element of the set of real numbers. Sorry, my R kind of got a little crazy there. Okay, our range is a little different. Our range cannot be low, like we're not going to be allowed to have any y values that are less than negative 3. So we'll say y, where y is greater than or equal to negative 3. Okay. Oh, and also we want to say that those are real numbers as well. So let's say that y has to be within the set of real numbers. Okay, so y is real numbers greater than or equal to negative 3 is basically what we're saying there. The direction of opening is up. Okay. The equation of the axis of symmetry, well, this is a horizontal line. Okay, it cuts through x equals -1. So the equation of that line, the axis of symmetry, is x equals -1. And yeah, and then we were supposed to sketch the graph after that, which I didn't do. I did it at the beginning. Sorry. Okay. So that is our first one. Okay. Let's try our second one. Oh, I just went down actually. Okay. So our second one is going to be y equals -1/4 x minus 4 squared plus 1. Okay, so our p value is 4, the q value is 1, k is, and a is -1/4. So it's going to be a little wide, and it's going to open down. Okay, so again, I guess I'll just get myself a piece of graph paper. And there's a couple more things. I know that the axis of or the domain and range, since it opens down, I know that my vertex, let's just write my vertex as well. My vertex is 4, 1. So since it opens down, I know that 1 is going to be my maximum value. Okay, so my domain, as always, is going to be equal to the set of values of x, for which x is just any element of the set of real numbers. And for my range, I'm going to be allowed to have values of y. Okay, I can't have a y value greater than 1, so they have to be less than or equal to 1. I got to write this properly. Less than or equal to 1, and also out of real numbers. And you know, sometimes if you have a specific real world problem or something, maybe it won't be appropriate to have it as any real number. You know, maybe only integers will be appropriate. So it's really important to state that. Okay, and then my axis of symmetry is just going to be the horizontal line that passes through my vertex. And so the equation of, or sorry, vertical line. Vertical line, I hope I said that up there too. A vertical line has a x equals some number as its equation, so it's just going to be x equals 4. That's going to be the equation of my axis of symmetry. Okay, so starting here with my x and y axes. Alright, and it's opening down, hey? I should have put, since it's opening down, I'm just going to make a little room for that. Okay. Okay, so that'll be my x, and there's my y-axis. Okay, so I'll put my vertex. My vertex is going to be at 4 and 1. Okay, that's my axis of symmetry. I know it's opening down, and what I can do is just make a little table of values, and maybe I'll make my x value and my y value. Maybe I mean I can make my x value -4, because I know that's actually going to give me my y-intercept. I can try an x value of, I can try an x value of, sorry, why did I say -4? I'm sorry. X is equal to 0. That's going to give you my y-intercept, not x equals -4. And then I can do one in the middle if I want. I can do x equals 2. That would be 2 good points to do. So when I substitute 0 in for x, okay, I end up with, wait a second. Right. When I substitute 0 in for x, I end up with -4 in the brackets. I square that, I get 16. -1/4 of 16 is -4. So +1 is going to give me a value of -3. Okay? That's my y-intercept. And if I put a value of 2 in, I'm going to end up with a -2 in the brackets. That's 4. -1/4 is, of 4 is -1 plus 1 is 0. Okay? So just substituting those x values in, finding what the corresponding y value is. And so this is going to look like this. Okay, if this is the axis of symmetry, I can just reflect each of those points to get another point. Okay, so this point here is going to have this reflection in the axis of symmetry. This point will have a reflection here. Okay, so we're going to have a nice smooth parabola opening down. Okay?